So we're supposed to consider a population that has a mean of 900 and a variance. Okay, so that's our mu, and that's our variance. So we're supposed to find the sample mean, and we know that that's the same as the overall mean, and we need to find the sample variance. So that's which, as you'll recall, is the same thing as the variance divided by the number of, the sample size there. So we need to do 121 over 100. Which, we can simplify that down to 1.21, can't we? And finally, we need the standard error. So that will be, we just need to take the square root of 1.21, which I get as, 1.1. So that's, all right, that should do it. All right, this problem is secretly going to look a little bit like a normal distribution. Okay, it's going to kind of look like this. We're going to need a mu, and we're going to need a standard deviation out of it. However, we're going to have to do some calculations to get to that, because this is going to be a binomial distribution approximation. So n, in this case, is going to be, they're going to make 20 attempts, and the probability that they hit it is 70%. So mu is going to be just 70% of 20. So on average, they're going to make 14, but we need to know at least 10. Okay, so let's take a look at how we can do that. We need a z-score for 10 compared to 14. And our standard deviation is, we haven't calculated that yet, have we? All right, I get 4.2. So we get negative 4 over 4.2, which is about okay, if that's the value that we've received, we need to now look it up in the back. And I get something like, let's see, we really only need the 2 places on that. Okay, so with that value, plus the 50% from before, and that should do pretty well. Okay, so marketing class makes a random selection of 150 shoppers at the shopping mall. They found on average 60%. Okay, so that's N. 60%. I think that's going to be our average, is 60. With a standard deviation. Oh, that's going to be our standard deviation. Okay, so let's set this up. N is going to be 150. Our sample average is going to be 60%. And our sample error is going to be 1.3. So I need to set a 95% confidence interval. That's going to be my Z star becomes 2.0. Okay. So all I need to do is set up my confidence interval. Okay, so the values that I have tell me that I should set it up to be 60 minus 2 times 1.3 over the square root of 150. And I should do this on both sides and then throw it into a calculator. So after running that calculation on Desmos, I get something like 59.8% to 60.2% for my 95% confidence interval. All right, let's take a look at this Puget Sound Special Olympics. We've got 65,000 raffle tickets sold at $150 a piece. There's a grand prize, which is $4 million. Second prize is $50. Third prize, 7 fourth prizes. Okay, so there's one each of those. So we need to calculate an expected value for this raffle, buying one ticket. So we could do this as and the probability of getting that. So overall, let's see. Okay, I'm going to organize this. Grand prize, second prize, third prize, and then fourth prize. Okay. How much is it worth? So there's 1 out of the 65,000. 1 out of the 65,000. Oop. And 1 out of the 65,000. Fourth place, there's 7 of them, right? So there's 7 out of the 65,000. And then the rest of them I need to also take into account, don't I? But they're going to have a value of 0. So this one's worth 4 million. This one's worth 50,000. This one's worth 10,000 and 5,000. Okay, so what I really need to calculate out of all of this is the expected value. So that's just going to be multiplying straight across. Okay, and then all I have to do is add them up. So just to add up each one of those values. I notice that they're all over 65,000. So on the top we get, let's see. Okay, so this appears to give me something like 63. Now, here's the big problem. Each one sold at 150, so I need to do 63 minus $150. And that gives me a negative 87. So the expected value is negative $87 for each ticket.